Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello there. So, let's continue to lesson number 2 for week number 7, which is integrating technique of integration. So, for lesson number 2, we continue with integrating rational function. Usually, we define a rational function as a function divided by another function. For example, we have fx divided by gx. And not only the function with power of 1, it could be anything, but commonly the power for both function is only 1. The whole function with power 1. Okay. So basically from the related to the previous lesson, okay, we focus on different integrating of product function when two function that multiply together. Okay, the same method previously kita dah discuss about integrating by substitution and also integrating by part, and I really hope you already check out the video and try to get familiar with this method. Alright, but for integrating quotient, I think kita boleh skip for by substitution because we already discussed in the previous video. But for this video, for this time, we focus on these two. The yellow one, which is long division ataupun long divide first to put it into quotient and remainder form. Okay, kalau masih ingat lagi quotient remainder form macam mana bentuk dia. Okay, kat sini letak kat sini which is px stand for polynomial divide by the divisor equal to quotient plus remainder divide by divisor. Okay, kalau you lupa, don't worry, nanti in exam I put in the question. So again, I repeat again, your polynomial or your numerator divide by your denominator will equal to quotient. Quotient ni kalau kita direct translate is hasil bahagi. Hasil bahagi. Kalau long division, kedudukan setiap elemen ni, okay, inside here is the px, the polynomial. Just beside here the divisor. Atas pula ialah quotient. Okay, and then kalau ada baki, ini kita panggil sebagai remainder. Alright, so ini adalah dia punya location kalau dalam long division. Alright, usually kita akan bagi saja quotient and also the remainder. Okay, tapi actually in calculus we write the quotient and remainder form is going to be like this lah. Ini dia quotient and remainder form. Okay, and then the second method, integrating quotient by simplifying the fraction. Right, so simplifying by fraction ni actually kita dah buat in the first lesson, which is how we simplify the fraction first, baru kita integrate. Okay, don't worry, kita ada example later. Okay, so let's take a look for the first method, which is quotient and remainder form. Alright, so some rational function are best handled by writing in quotient plus remainder form. First, remember that this is done by dividing the denominator into the numerator. Okay, contoh, integrate 3x plus 2 divided by x minus 1. If you can see from here, you cannot even split. Jangan tiba-tiba you split 3x plus 2 over x and then minus 3x plus 2 divided by 1. This is totally wrong. We cannot even split the denominator. But what we can do is kita boleh gunakan long division. Alright, I really hope you masih lagi ingat on how to solve the fraction by using the long division. Okay, so in this example, your px kat atas ni, your px, your polynomial will be 3x plus 2. Outside the bracket, which is your divisor, dx, so x minus 1, right? So you multiply by 3 to your divisor, so therefore you will have a remainder of 5. Okay, so sebab itulah you dapat sini ialah ini kita panggil sebagai apa tadi? Your quotient. Number 5 ni ialah your remainder, and then your x minus 1 is the divisor. Okay, barulah kalau you tengok, barulah kita integrate yang ini, which is this one is actually the result after we perform the long division. So therefore it's easy to integrate compare yang ini. Alright, so if you notice over here, we integrate separately. Integrate 3 become 3x. Integrate 5 divided by x minus 1. This one you have to treat like a reciprocal, which is the whole function ni power the 1, right? So therefore, integrate reciprocal function, take out the constant, put outside, which is 5. Okay, and then integrate 1 over x minus 1 become ln with modulus x minus 1, and don't forget to put plus c, right? Okay. For this example, okay, yang this one is more on what we call as the simplifying the fraction lah. Okay, so this method can also be used with some other rational function where the numerator and or the denominator are not linear. Kalau tengok your numerator is a quadratic. It's a quadratic. Actually, you boleh gunakan juga the long division if you want. Okay, at the end nanti akan dapat macam ni. Okay, but without kalau tak nak gunakan long division, what we can do is you boleh identify the common factor for the first two term of your polynomial, right? Okay, after that you boleh cancel out. Okay, you boleh separate. Okay, after that you boleh cancel out. Actually, they skip one step over here. So what we do is x plus 1 over x plus 1 minus 1 over x plus 1. Right, so you boleh cancel out ke sini, hilang, so therefore you ada x, right? And then this one you nothing happen over here, you just rewrite sahaja. Okay, after that you just integrate both. Okay, so basically kita ada dua method lah. If you wanted to use the long division, or sometimes tak perlukan long division, what you can do is identify the common factor for both. Alright, okay. And this one is simplifying the fraction. Okay, this is the last method, the third method on how we integrate the rational function, not the rational function, the fraction. Okay, so which is we simplifying the fraction. This is what I mean. We already done in the first lesson. You can see from here we divide for each term with the x cube. Okay, nampak they divide what? Every single term ni dengan x cube. So after that the remaining is only nil, x 1 over x and negative 2x for negative 3, and then you can easily integrate. If you wanted to use the long division also can. After that you just integrate like usual. Okay, I think no need to further explain about this part because already explained in the previous video. Okay, so let's try this exercise 20.07. I choose only 3 questions, and I believe you will try the rest of the question later. Okay, so let's try with this question number 1. We start from the basic, from question number 1. Okay, I wanted to use the long division. Alright, so remember the long division, the result should be in the form of quotient plus remainder. Alright, so your px divided by your divisor equal to your quotient plus your remainder divided by the divisor. Okay, so kalau kedudukan dalam long division, remember inside the bracket over here is your polynomial, outside the bracket is your divisor, on the top will be your quotient, and your result will be your remainder. Okay, now so let's integrate using the long division first. Okay, so x plus 2x plus 3 divided by x plus 2. So the suitable multiplication over here is 2. Multiply 2 with x plus 2, therefore you akan dapat 2x plus 4. And then subtract these two. 2x minus 2x is 0. X minus 4 is negative 1. So therefore, in the quotient plus remainder, what do we have? Yes, correct. 2 plus your remainder negative 1 over x plus 2. Simplify, you akan dapat 2 minus 1 over x plus 2. Okay, now I believe this is easy to integrate. Integrate 2 minus 1 over x plus 2 dx. Okay, so kat sini soalan dia 2x plus 3 over x plus 2 dx. Alright, now integrate 2. Integrate 2. Over here actually 2 times x power 0. Remember, add 1 to your power of your x and then divide by the new power. So integrate 2 become 2x. Minus over here you will have a ln and with modulus of x plus 2. And then don't forget to divide with the function. Differentiate your function. Okay, so finally you have 2x minus ln x plus 2 plus c. Kenapa plus c? Mana hilang divisor? Because differentiate x plus 2 is 1. Okay, so this is the answer. Okay. Let's continue a bit further with question number 12. Okay. Obtain this in definite integrals. Again, I'm using the long division. Easy for us to determine the hasil of this these two fraction. 2x minus 1. Inside here, you put your polynomial. Okay. So, what is the suitable multiplication in order to solve this 4? In order to cancel out this 4x cubed? Of course, you will multiply with 2x squared. So, you akan you will have 4x cubed, and then alright, so actually ada a bit mistake here. Kenapa mistake? Because we have to put the missing term, okay, which is you add 0x squared and then copy semula plus 1. Kenapa kena letak missing term? Because later you will bring down the element, right? Okay, so sebab itulah kena ada missing term. You put as a multiplication of 0 to your missing term. Okay, now minus, kat sini you will have minus 2x squared. Okay, so therefore you will have over here is 4x cubed minus 4x cubed 0. 0 minus 2x squared, you will have 2x squared. Okay, now you bring down negative x over here. So the suitable multiplication is x. So therefore you will have 2x squared minus x. So subtract these two, you have 0 and 0. Bring down 1. So there is nothing that we can multiply, put into the quotient. So therefore we decide this one as a remainder. Okay. So as a conclusion, kita label lah. So this is our divisor. This is our quotient. This is our polynomial. And last but not least, this is our remainder. Okay. And then we put in the form of quotient plus remainder form. So integrate of 4x cubed minus x plus 1 over 2x minus 1 dx is actually equal to integrate of quotient, which is 2x squared plus x plus 1, your remainder, divided by your divisor, 2x minus 1 dx. Okay. Now it's easy to integrate compared to the original question. Okay, now integrate 2x squared. This become 2x cubed over 3 divided by the new power. Don't forget. Integrate x, you will have x squared over 2 plus, over here you will have ln 2x minus 1. But don't forget to differentiate the function. And plus c, simplify further, 2x cubed over 3 plus x squared over 2 plus 1 over 2 ln modulus 2x minus 1 plus c. Okay, which is differentiate 2x minus 1 is half. So sebab tu I put in front of the ln. Okay, so this is the answer. Alright, last but not least. Alright, so this time number 15. If you wanted to use the long division, go ahead, but we can use the simplifying the fraction. Okay, kenapa? Because you ada single term for your denominator. So you divide for each term with your denominator plus 1 over 2x squared dx. So simplify, or you will have 1 minus 1 over 2x plus 1 over 2x squared dx. Simplify lagi, 1 minus 1 over 2 1 over x plus 1 over 2 x power of negative 2 dx. Okay, kenapa I take out the constant? Okay, because I nak focus on differentiate the function only. Okay, constant ni later kita boleh multiply, so don't worry about the constant over there. Okay, so we focus on differentiating the constant. Differentiate the function. Okay, differentiate 1, you will have x, and then 1 over 2. Alright, differentiate 1 over x. This is a reciprocal. Okay, commonly, student akan bring up and then put as a power of negative 1. Okay, and then once we integrate, nanti later, negative 1 plus 1 jadi 0. So, this is a major mistake. So, ini kita classify as a reciprocal function, which is the highest power of x over here is 1. Not the highest power of x. The whole function at your denominator is 1. The power for the whole function is 1. So, ini kategori sebagai ln. Reciprocal function. So, sebab tu bila you differentiate 1 over x, you akan dapat ln modulus of x. Plus 1 over 2 differentiate x power of negative 2. Remember, negative 2 plus 1 divided by the new power plus c. Okay, so what do we have? X minus 1 over 2 ln modulus of x plus 1 over 2 x power negative 1 over negative 1 plus c. Simplify again. 1 over x minus 1 over 2 x plus c. Alright, so this is the last question for lesson number 2, and I believe you can try for the rest of the question. Okay, ada 15 soalan, boleh try. Okay, try to use the different method. You boleh gunakan substitution, you boleh gunakan long division, you boleh gunakan simplifying the denominator, not simplifying the fraction. Alright, so see you to the next video. Assalamualaikum warahmatullahi wabarakatuh, and thank you.